Hi friends, welcome to the Unit R Day 4. This is the factoring packet. These are an additional supplementary set of notes that we're going to go over. So here's some examples that we're going to work through together. First, this is just a review of the four-term factoring. So this is either the grouping 2 and 2 or the 3 and 1 method. Remember, the 3 and 1 involves having perfect squares. So for this first one, I'm just going to check first. I've got what looks to be like a grouping of 2 and 2, and the reason I see that is I see no perfect squares. So check perfect squares first. If you're confused on if it's going to be a grouping or a perfect squares, check to see if it's perfect squares first. No perfect squares. So I'm going to go ahead and group. It looks like that might be able to group as is without having to rearrange anything. So I'm just going to see, all right, what are my greatest common factors that I can take out of a 7AC and a 42BC. So a 7AC and a 42BC, I can pull a C out. I can also pull a 7 out as well. So if I pull out a 7 and a C, I'm left with, when I divide 7AC by 7C, I'm left with A. When I divide 42BC by 7C, I'm left with 6B. So I know now, whatever I factor out of the second one, I need to be left with an A plus 6B, or else it doesn't work. So for this next one, I can factor out a 3 and a D from both of these. When I do that, I'm left with A plus, and then 18BD divided by 3D is 6B. A lot of students, what they'll do is they'll be like, Mr. Brumman is just setting it up so that it factors nicely. I don't have to worry about checking. Please check. They don't all do that. Some of them are actually kind of a disguise. It looks like that it's going to be factoring this way, like what we're just doing, but it's actually a different way. So don't fall into that trap. With this, now, what I have is I can factor out from both of these terms. So these are two terms. This is a term here, and this is a term here. A lot of students struggle with this part, and they just magically go to the next step, not really conceptually understanding why. I can factor out from both of these terms, I can factor out an A plus 6B. So if I'm taking an A plus 6B out of both of these, what is left? Well, in this first set, you're left with a 7C, and the second set, you're left with a 3D, and that is why we can factor by grouping this particular set. We're left with that actual value. That's number one. Number two, looking at this, I automatically see, perfect squares. So your mind should go into the 3 and 1 method. I do see that it's not really grouped well. So when you see the 3 and 1 method, look next, after you see the perfect squares, look next for a negative sign, minus sign. That's going to tell us kind of, okay, this is what needs to go in the last term spot. So I see that I've got a minus y squared. So if I just rearrange these, I know the minus y squared is going to be in the last term. Now setting it up for the rest, you should have an x squared. I use x squared because the x squared is given this problem, but your x squared plus bx plus c, that needs to be in the first part. So x squared plus bx plus c. In this case, b and c actually have constants, coefficients, so this gives me 8x plus 16. So this is the 3 and 1 method. So the way that we do this, going through each of the steps, I'm going to set up, so I'm going to factor out my y squared, knowing that that's the last part. So that's going to give me a plus y and a minus y. Now to think about, for this x squared plus 8x plus 16 part, what's going to give me the values that's going to get me, when I add them, when I multiply them together, what's going to give me that 8x? Well, 16, if I take the square root of 16, that gives me 4. So this is going to be 4. So I have x plus 4 here, and then also x plus 4 here. So I have x plus 4 plus y, and then x plus 4 minus y. So that specifically is very similar to what we did on the example that we talked about in this set, except you notice that instead of a minus 8x, this is a plus 8x. So that's how this works out differently with each part. So this tells you kind of how it factors out. So this is the factors for this one here. Next, for number 3, I do not see any perfect squares, so this looks like a 2 and 2. Looking at this first set, It looks like this might work if I factor it out with 3. I could see a 3 and an x. And the second one I can see negative signs, maybe a -4 or a -2, and an a. So let's try it out with just how they are with grouping. Let's see if it works. So if I factor out, let's see, looks like a 3 and an x from this first one. And then I'm left with 2b, or not 2b. And then 3x, and then 21xy. So that gives me, if I divide those, 21xy divided by 3x, I get 7y. So again, I need to end up with 2b and 7y in parentheses in my next one. Sometimes what I'll do is I'll just check, okay, if I divide a 2b out from this -8ab, what do I have left? And that helps me figure out what I should have in front for this to work. So again, kind of going a different method or kind of a different approach to solving this, or simplifying, but it does work if it works in grouping. So 2b goes into -8ab, -4a times, left with a 2b, and then -4a from a -28a, that's going to be a +7, and then y. Hey, look, it works. So now I can go ahead and pull out, again, factoring by grouping, pull out the 2b plus 7y from both of these. And then 3x minus 4a is the other term. So there is number 3. Number 4, oh, I'm seeing a perfect square. So a lot of students will jump to the 4a squared being perfect square. You are exactly right. It is a perfect square. After you jump to seeing the perfect square, check to see where the negative sign is. This is a -16b squared. That's also a perfect squared. And if I look, there's no more b's in this. That tells me that's going to have to be my last term. It has to be my last term. 4a squared minus 12a plus 9. And then this last term has to be -16b squared. How did I know it was -12a plus 9? Again, going back to what we talked about earlier, that's that ax squared plus bx plus c pattern that we talked about. So make sure that you're focusing on that. Again, setting it up. So my sets of parentheses, I'm going to have a plus and a minus here at the last terms. I know that it's going to be 4. If I take the square root of 16b squared, I get 4b. So I'm going to have a plus 4b and a minus 4b. That's my last terms in both. So now for this beginning part, to get the terms, you take the square root of 4a squared. So this is 2a. That's 2a. And then to get this to be a -12, I know it's going to be minus minus. Then the square root of 9 is 3. So I have 2a minus 3 plus 4b, and 2a minus 3 minus 4b. You can clean that up for spacing if you wish. I'm going to clean up for legibility. 2a minus 3. There we go. There's the factors of that one. For number 5, I have y squared minus 4y minus 9x squared plus 4. Again, seeing that this is a 3 and 1, it is a factor by the 3 and 1 method. My perfect square, again, don't jump to the y squared. It doesn't have a negative sign. It's that -9x squared, so I'm going to have to rearrange these. So I have y squared minus 4y plus 4, and then minus 9x squared. So now if I go through and do a factor by 3 and 1 method, I've got, for this part, again, you may notice I always work from the back. I start from the back and then work my way forward. Start from the back and then work my way forward from there. So that's going to give me, let's see, plus 3x. And I've done the positive one first. It actually doesn't matter on the order. You could do the minus or the plus, doesn't matter. And then minus 3x on this one. As long as you have 1 minus and 1 plus for this last part. Now if I go ahead and take the square root of y squared, I get y, I get y. And then to get my middle term to be negative, both of these will need to be negative. So I have y minus, and then the square root of 4 is 2. So I have y minus 2 plus 3x, and y minus 2 minus 3x. So those are my terms. And the last one is number 6. Number 6 looks like it's going to be a factor by grouping. Just looking at this, it looks like it might work out well the way that it is right now. I don't see any perfect squares. So then let's just jump in and see how this works. I may have to move some grouping around. Let's find out. So for this one, I've got an x squared in both of my beginning terms. I'm going to factor out the x squared. And what am I left with? I'm left with a 3y, and then looks like a minus 5. Okay, so now, seeing that this is a positive 3y, and I have a negative 12y here, to factor this out, that's kind of a red flag. Like, hey, make sure that you remember to get a negative. Here, we're going to have to factor out a negative. So I'm going to have to factor out a negative 4. So that's negative 4. And then what I'm left with is, so negative 12y divided by negative 4 is a positive 3y. 20 divided by negative 4 is minus 5. So now I have my factor by grouping, which I can go ahead and do. So I have a 3y minus 5 and x squared minus 4. Now you may think, oh, I'm done. Wait! X squared minus 4. You can factor that. Don't stop until you're done factoring. Factor everything completely. So this is a 3y minus 5. This is the difference of squares. We talked about that in an earlier section. And you get x plus 2 and x minus 2. Again, order doesn't matter. You could have these in any order as you went and put them in your final answer. Thanks for joining me in this video. I'll see you in the next one.